Imagine yourself drawing a wave, the smooth rise and fall. That's what we explore today with sine and cosine functions. These functions are not just math on paper. They represent rhythms of life, from the oscillations of a pendulum to the ebb and flow of tides. Let's start with the sine function. Picture it as a wave starting at 0, rising to its peak, and gracefully returning to 0. Now enter the cosine function. It's like a sine wave, but shifted to the right, beginning at its highest point. Both functions have a pattern that repeats, known as the period. For sine and cosine, this period is a. What about their amplitudes? That's the height from the center line to the peak. It shows how far our wave stretches. Consider how these waves change when we adjust their equations. A small tweak can make the wave taller, shorter, or shift its position. Let's graph a basic sine function. We start at 0, rise to 1, drop to -1, and return to 0. Next, overlay a cosine graph. Notice how it starts at 1, while sine starts at 0, yet they follow the same shape. This visual overlap demonstrates their phase shift. Cosine leads sine by a quarter cycle. Now, think of applications. Engineers use these functions to model waves, design circuits, and even in computer graphics. In music, sine and cosine help in understanding sound waves and produce different tones and beats. In nature, these mathematical concepts help predict natural phenomena like weather patterns and planetary motion. Back to our graph, if we increase the frequency, the waves get closer together. This shows faster cycles or oscillations. Decreasing the amplitude makes the wave flatter, used in damping vibrations in cars and buildings. Imagine adding multiple sine waves together. This can create complex patterns, mimicking real-world scenarios like varying tides. In conclusion, the dance of sine and cosine is everywhere, encoding the rhythm of the universe in the language of mathematics.